Okay, so looking at this one, the question 13, so we've got our sequence of numbers 1, 4, 7, 10, etc. So hopefully you can see that sequence is going up in threes. And we can say the first term of the sequence is 1. The second term is 4, etc. So notice here, point A, because the first term is 1, the first term is 1. Point B, the second term is 4, so that's given us the coordinate point B. For C, the third term, if we look up here, the third term is 7. So the third term 7, and similarly part D, point D rather, the fourth term is 10. So they've plotted those ones on the graph and then extend it to include as many terms as you can. So you could work out the fifth term, the sixth term, the seventh term, all the way up to the 10th term of the sequence, and the 10th term will be 28, I think. So if you plot that one on the grid, that'll be somewhere around there. And what they should form, if you carried on plotting them, they should form a straight line. So the equation of the line for part B, so the equation of the line, remember, is always in the form y equals mx plus c. So m is your gradient of the line. Now we talked about here the points going up in threes. So as you increase from the first to the second term, this has gone up by 3. As you increase again, it's gone up by 3. So this value here for the gradient will be 3. So it's going to be y equals 3x plus some mystery number. And to find that mystery number, what you can do is choose any point that you know the graph goes through. So I'm going to choose point D. So I know when x takes a value of 4, so the fourth term of my sequence, when x is equal to 4, y is equal to 10. So I'm going to substitute those into this equation here to find that mystery number, because I can't really extend my graph down to see where it's going to cross the y-axis. I can see it's going to be a negative number there. So when y is 10, x is 4, so I'm going to substitute that into there, and I get 10 equals 12 plus c. That must mean that c is equal to minus 2, and that would look about right if I look at my graph. So my equation is y equals 3x minus 2. Right, work out the nth term of the sequence, and it says, what do you notice? So the nth terms, so we've got our sequence of numbers 1, 4, 7, 10, etc. So we know they're going up in threes. So we know another sequence of numbers that goes up in threes, and that's our 3 times table. So if I write out my 3 times table, 3, 6, 9, 12, etc., hopefully you can see there that if I get my numbers in the 3 times table and then I subtract 2 from all of those numbers, I get the terms in my sequence. So if I work out the numbers in my 3 times table and then I subtract 2, that will give me my nth term. Now I chose to use the letter n there, but I could have used x instead. I could have said that's my nth term. So work out the nth term sequence. What do you notice? And you should notice there's a link here between the line and my nth term. What would be the 20th term of the sequence? So to find my 20th term, I need to let n be 20. So my 20th term, I'm going to let n be equal to 20. So I'll do 3 lots of 20, 60, take away 2. My nth term should be 58. So my 20th term is 58. Is 23 a term in the sequence? Explain why. So, can I have a number of 23 for the nth term? Can my 3n minus 2 ever be equal to 23? I know it can be equal to 58, because I know if I make that equal to 58, I'm able to add 2 to both sides and then divide by 3. And I know my 20th term is 58. But is there a term that produces an answer of 23? Well, if I go to solve this equation and I add 2 to both sides, I get 3n equals 25. If I then divide by 3, that's going to be giving me 8 and a third. Now, I can't have 8 and a third at the term of the sequence. I can have the 8th term of the sequence, I can have the 9th term of the sequence. But in this case, I can't have the 8 and a third term of the sequence. So 23 is not a term in the sequence.